Okay, ladies and gentlemen, this is Getting Ready 1.0, just getting us ready for what is going to lie ahead in Unit 1. So we're going to go through a bunch of algebraic expressions and solve them, figure out what the values are, and try a couple problems. First one that we have in front of us is evaluate 3x minus 2y plus 1. And we're told that x equals 4 and y equals 3. So if you know the value of the variable, all you need to do is sub it in there. And you just want to be a little bit careful with how you write it in there. What's the operation in between the 3 and the x? Multiplication. So because I'm substituting a value in for x, what am I going to want to remember to do to that value? I'm going to want to put it in brackets so that I can separate it from the 3 and understand that it's still multiplication. So I'm just going to rewrite the problem, subbing in what I know. 2y means 2 times y, so I have 2 times 3 because I know y equals 3. And I'm going to add 1. One key note for form, because I'm rewriting the expression, I want to let everyone know that my new expression in red is equal to the original blue expression where x equals 4 and y equals 3. Okay, these are equivalent statements, so I need to write an equal sign when I go to my new line. Now I'm just going to perform those operations. I'm going to start with multiplication, and then it looks like I have subtraction and addition. So step 1, here's a 3 times 4 is 12. And then I have minus 2 times 3. 2 times 3 is?
6.
Is 6. Okay, I can think about this two different ways. I can think about it as negative 2 times 3, which is negative 6. Or I can just bring down that subtraction sign and then just do 2 times 3 is 6. Okay? And they're equivalent statements. And now I do my subtraction and addition left to right. So I have 12, take away 6 is?
6.
Plus 1 is?
7.
All right, there we go. Problem number 1. Our next one across the way there is evaluate b minus 1/2 a when a equals 4 and b equals negative 1. While I'm writing, always double check that I write what's actually in your notebook. If there's a problem, then you need to tell me right away so that I don't keep on going with that. Yeah? Okay, so we've got b minus half of a. You can say this in a couple of different ways. This is half of a because I know there's multiplication and the word of represents multiplication. I could also say this is a divided by 2, a over 2, because this a is in the top. It's 1 times a in the top divided by 2. Anyway, half of a. We already know what a and b are, so I'm just going to rewrite my statement, but at the far left I'm going to remember to include a equal sign. Thanks very much. B is negative 1. I'm going to bring down that negative sign. 1/2 times a. What am I going to do with the value of a, which is 4? Put it in brackets. Good. And now my order of operations. I see I have just subtraction here, so I'm going to go over to the second term, which is half of 4. 2. Or 4 divided by 2 is 2. So I have negative 1, copy that down, minus 2. All right, I'm in negative land. I'm at negative 1. If I do a quick number line, here's 0, here's negative 1. I'm at negative 1 already. In which direction am I going?
That way.
Yeah, deeper into negative land, 2 more. Boing, boing, to negative 2 to negative 3. Okay, hopefully that's a little bit helpful. Basically, I'm adding negatives. I have 1 negative, and I'm going to add another 2 more negatives, which is going to bring me to 3 negatives. Negative 3. Okay? Good, good. Okay, in our next one, we are simplifying expressions. Simplifying expressions. The first expression that we have is 3, and then we have a group that's x plus y minus 2 times the group x minus y. So before we dig into this, a couple things you need to know. Groups stay together. And what I have here is, and we can think this through, I have this group 3 times. So how many x's do I actually have here? 3. How many y's do I have?
3.
Let's look over here. Ignore the negative for a second between just here. How many x's do I have?
2.
How many negative y's do I have? So I have negative 2y here, right? And I'm going to have 3y's here. I'm going to have 3x's here. I'm going to have 2x's here, but this whole thing's going to get subtracted. Okay, there's a couple different ways that you can do this. What I'm going to do is just take down this negative 2 each time. Do you guys remember the word distribute? Okay, so basically what I'm going to do, we just thought it through, so we kind of know what it's supposed to look like. But what I'm going to do is I'm going to distribute this 3 to the x and to the y. That's going to help me remember that everything in this group needs to be multiplied by 3. I need 3 of these. I need 3 x's and 3 y's. So that's what our next step is going to look like. 3 times x. I know it's multiplication because there's nothing in between the 3 and the group, so multiplication is implied. So I have 3 x's and 3 y's. Okay? Now on this next one, I'm going to bring down the negative sign and then do this stuff over here. So what I'm going to do is I'm going to bring down this negative sign, and I'm actually going to let everything else that happens stay in a group. Okay? And then I'm going to apply that negative sign to it after we're done. Basically, all I'm going to do now is distribute the 2, which I'm considering a positive 2 because I brought its negative down already. So I have 2x, and then I have 2 times negative y. That's going to give me negative 2y. Okay? Now I actually still have multiplication. I still have a group that I need to break up. But what I have to remember is that this negative, I want to subtract this whole group. So this negative sign applies to this term and to this term. I'm really distributing an invisible negative 1 there. So what's that going to look like? Well, I could copy down my first two terms, 3x plus 3y. And now I have negative 1 times 2x. Basically, all that's going to be is negative 2x.
Plus 2.
And now I'm going to have a negative 1 times negative 2y. So my value is not going to change. It's going to be 2y, but I have a negative times a negative, which is going to give me a positive. So you can see what this negative did to the sign of this term. It was positive, now it's negative. And the sign of this term was negative, now it's positive. Multiplying something by negative 1 will flip the sign. It will change the sign. Now what can I do? Now I can group like terms. So I have x's here, and I have y's here. Well, how many x's do I have? I have 3, take away 2, that leaves me with 1x. And y's, I have 3 plus 2, 5 y's. Okay? I said there was another way to do this, so I'm just going to do it really quickly. This step, I didn't need to necessarily leave the negative out. I could have done it all in one step. So let's say I distributed this side and I'm just going to move it over here. You don't need to write this if you don't want to, but please watch. 3x plus 3y. And now here, if I considered this all one group, that's an easy way to do it too. What I'm going to end up getting is negative 2 times x and negative 2 times negative y. Okay, you can see how that eliminated this whole step, and we actually have the exact same thing here and here. All right, so you can either deal with them separately, deal with a positive 2 and bring down the negative, or you can deal with a negative 2 and distribute that to both terms inside the bracket. Okay? Okay, the next one that we have as a practice problem is a little bit longer. Simplify x minus 2 times, and then in brackets, x plus 3y, close bracket, subtract, in brackets again, 2x plus 3y, and subtract 4 times x plus y. Go ahead and try that on your own. The first step, again, we're going to distribute into the groups. So you have a distribution here. You have a distribution here, which is a little bit tricky. You're going to be distributing negative 1 to both of these terms. And then you're going to distribute negative 4 to both of these terms. By the time you're done that, your next step should have no brackets left. No brackets. See if you can do that. When you're done, you can go ahead and check the board for your next step. Just be sure that your signs are the same as my signs. I'll talk through it right now. So we had a -2 getting distributed to an x, giving us -2x. And distributed to the 3y, that's going to give us -6y. That's a typo. Mistake, Mr. V. Okay. Then we had this -1 getting distributed to the 2x, giving us a -2x term and a -3y term. Notice that group didn't change, it just flipped the sign in front of each of the terms. And then we had -4x's and -4y's. Now, in this next step, we are going to group like terms. So I like to give them a little bit of an underline just so I can make sure I know that I'm getting all of them. Here's the x's, okay, and here's the y's. Once I've done that, I can be sure that I'm going to include all of the information. So I've got x minus 2x, so I'm at +1. I'm going to take away 2. That's going to leave me at -x. I could write that and then keep going, but I'm actually going to do all of the x's in my head. So I'm at -1. I'm going to go down 2 more. -1 minus 2 is -3. So I'm at -3 x's. And then I've got -4 more. -7 x's. Let's look at our y's. We're starting at -6. We're going to go down 3 more. So -9. We're going to go down 4 more. -13. -13y. Okay, that's as simplified as this one gets. Good job. All right, let's look at percents. Percent. Okay, you guys had French class this morning. What's the word cent mean? 100. Okay, so this is per 100. That means you can take any proportion, any value, and you can turn it into a percent. You can say it's this many out of 100. So if you had a test and your test was out of 25, that's great. You got, let's say, 20 out of 25. You could also find out your percent, your mark out of 100. Well, if it was out of 25 and you actually want it out of 100, you need to find out the value that will give you an equivalent statement on both sides of the equal sign. Well, how did we get from 25 to 100? We multiplied by 4. How do we, then we do the same at the top because you have to do the same. And you ended up with 80 out of 100, which is 80%. We understand that concept fairly well, okay? 80% is the same as 80 out of 100, which could be reduced. Same as 8 out of 10, same as 4 over 5. Okay, so if you had a quiz out of 5 points and you got 4 out of 5, you got 80%. 80%. Yeah, same as 8 out of 10. Same as 16 out of 20. Okay, and you could keep going and do that forever and ever and ever with an infinite number of fractions that all have an equal value. Yeah? Good. So our notes say, calculate the amount of salt in 10 kilograms of a 25% salt solution. Okay, so the first thing that we want to look at, we're told that this solution has 25% salt content. Okay, well, can we rewrite this as a fraction? 25%. Sure can. 25%. 25 over 100. Okay, a good way to visualize this is look at this little percent sign. It's got a 1 and 2 zeros. Okay, so it's 25 over 100. 25 over 100. Can we rewrite that as a decimal?
0.25.
0.25. Here's how you read that. 25 hundredths. Well, right here, 25 hundredths. If I'm in my second decimal place beyond the decimal there, my place value, that's hundredths. I have 25 of them, 25 hundredths. Okay? Now, why did we do that? Well, because we're told that we have 10 kilograms of 25%. What does that word of indicate?
Times.
Multiplication. Okay, so the whole bag is 10 kilograms, but we want to know how much is pure salt. Well, only 25% of it is pure salt. So all we need to do is take 0.25 times 10. Okay? And you can do that in your head or in your calculator. What you end up with is 2.5. And I look back into my problem, I see we're talking about kilograms of salt. So I want to make sure I include that in my answer. 2.5 kilograms of salt. Okay? Let's look across to the second one there. The second one is dealing with simple interest. I don't need to get into that so much, but if you put money away into a savings account, you earn interest on it, or you loan somebody money, you can collect interest. Unless you're brothers and sisters in Christ, then you don't gouge each other. But basically, we're going to calculate how much interest is earned on an investment. So this person is investing for 1 year. They're going to drop $1,000 into a savings account, and they're going to get 5% on it. That's pretty good for a savings account. So they're going to go, and we just want to know how much interest is earned. So we're going to get 5% of $1,000. Okay, I'm going to write this one out a little bit differently so that you can see what's happening. Well, what I need to do to this 5% is represent it as a decimal. 5% means,
0.05.
yeah, great, 5 hundredths, which is 0.05. Do not mix this up with 0.5. What's that?
50%.
Yeah, that's 50%. That's half. Okay? If you could earn half your money back in a year every time, you'd do that with every penny that you ever made. Okay? I would multiply it real quickly. Okay, 0.05 of, yeah, 1,000. And all I would do is throw that in my calculator, or if you're real quick, you know that 0.05 is the same as multiplying by 0.05 is the same as dividing by 20. Either way, you're going to shift this decimal place 3 spots backwards, so 1, 2, 3, and you're going to come out with $50 worth of interest. Typically, I wouldn't put my solution and my final statement in the same thing. You'd answer 50, and then you would write that you would earn $50 of interest in this account or something like that. Okay, but for the sake of speed, put it all in one. Is this good so far? Doing okay?
Yeah.
Cool. All right, Unit 1 is going to be a lot about graphing lines and intersections of lines. So if you have 2 sets of lines or 2 lines that are going to hit each other and you need to find out where they are, well, one helpful tip is being able to graph them or being able to find solutions along that line. So we're going to do that in a few different ways, okay? Graph lines. We're going to go with method 1. Method 1 is use table of values. All right, well, when we are graphing lines, and I'll just draw this. You don't need to draw this yet. Please don't draw this yet because we don't really know what it's going to look like yet. Basically, this is an axis, okay? This is a Cartesian plane, named after the guy who came up with it, René Descartes, okay? Cartesian plane has an x-axis and a y-axis. Now you can find your position anywhere on this Cartesian plane, anywhere on this grid, by knowing the value of x and the value of y at that point. It creates an ordered pair. Okay, don't draw any of this. You're just watching for now. But basically, if I knew that this was 1, 2, 1, 2, I'm just working in the positive x, positive y quadrant. There are 4 quadrants, 1, 2, 3, 4. Yes, you count them somewhat backwards like that. But basically, I would know that this point has an x coordinate of 2, and let's move the point so that it has an x coordinate of 2 and has a y coordinate of 3. So that value is this point is at the position 2, 3. It takes 2 numbers to tell me where this point is. If I just have one of those coordinates, it doesn't tell me anything. Actually, one of the coordinates would turn it into a line. If I just knew that x equaled 2, then it would be something like this. Okay? But that's what we're working with. So a table of values is going to give you all of those ordered pairs, in order to help you graph the line that you need to work with. So the example that we have here is y equals 2x plus 1. So I have two variables. I have what's called the independent variable and the dependent variable. The y, the value of y, depends on the value of x. As x changes, y will change. This equation is going to create a line because it has an infinite number of solutions. It actually is going to create an infinite number of points on our Cartesian plane, an infinite number of points in the form of a line. Okay, as x changes, y will change. You'll see that as we move along. So how do I create a table of values? Really easy, just like that. Okay, so I'm going to put in some values for x. Remember, x is independent, and I'm going to put in values that are going to keep us hovering somewhere around the origin. The origin is 0, 0. That's right here, the center of any Cartesian grid. Okay, so I'm going to choose x values 0, 1, 2, and 3. And then the value of y is going to depend on the value of x. So all I need to do now is I need to solve this equation with the number 0 for x. I'm going to write that answer here. Then I'm going to solve it where x is 1, where x is 2, and where x is 3. I'm going to do that work off to the side. A lot of this you should be able to do in your head, but if you can't, that's okay. Basically, in the first one, what I'm saying is that y equals 2x, but I know x is 0, so I'm going to put 0 in brackets, plus 1. And now I'm just looking at my order of operations. So to figure out what y is, all I need to do is complete this with order of operations. 2 times 0, if I have 0 2's, 0. Okay, plus 1, y equals 1. So when x is 0, y is 1. But remember, if x changes, y is going to change. So I need to do this again. I have the same equation, y equals 2x plus 1, but this time x is going to be 1. 2 times 1 is?
2.
Plus 1 is?
1.
So when x equals 1, y is 3. Okay, I'm going to do the rest of them in my head or just out loud with you. This time I have x equals 2, so I have 2 times 2, which is?
4.
Plus 1 more.
5.
2 times 3 is?
6.
Plus 1.
7.
Okay, so this gives me a handful of ordered pairs. This is going to tell me where things are on my grid. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8.
Want us to draw that?
Yeah, go ahead and do this in the grid that's provided for you to the right of these notes. Yours will look more beautiful than mine. You can go ahead and do some negative ones as well. -1, -2. By the way, lines extend forever. So even though we only have these values, I can plot those points. Plot those points means find the place on the grid where x is 0 and y is 1. That means x 0, y 1. That's right there, okay? This gives us the ordered pair, and maybe I can just show you what that looks like. So now we have the ordered pairs 0, 1, 1, 3, 2, 5, and 3, 7. All of those points are going to be on this line. This line is going to go through all of those points. Okay, so 1, 3 is right here. I go over 1, up 3. Notice the x coordinate is always first. x2, y5, x2, y5. And if I've done it properly, it should form a straight line. Does anyone know how many points you need to form a line?
2.
You only need 2. Okay, but the extras are here to help us double check. 3, 7 is up here. And now what I'm going to do is take a lovely straight edge. In my case, a ruler. There it is. And I'm going to draw a line. Make sure I go through all my points. Just like that. Okay? That is the line y equals 2x. Two things I'm always going to do on my coordinate grid. Okay? First of all, I'm always going to label 3 things, I guess, then. First of all, I'm always going to label my x and y axis. Okay? Then I'm going to give little arrows at the end points of my line, because there is no end point. A line goes forever unless you're told otherwise. And I'm always going to name the line. This is the line y equals 2x plus 1. That's its name. Okay? So the first method for graphing lines, use a table of values. You have the equation, select a few values for x, and then figure out what y is dependent on each value of x. That'll give you your ordered pairs, which you can plot on your graph, draw a straight line through it. That's the line y equals 2x plus 1. Okay? Good, good. Clearing this. To go on to method 2. Method 2. This is slope and y-intercept. Method 2, use slope and y-intercept. The equation that we have that we're going to work with is y equals 2/3 x minus 5. So the important thing to remember here is slope-intercept form. You probably learned about that last year. You'll talk about it a lot more this year. Slope-intercept form is the form, I'm just going to draw it right here, y equals mx plus b. Is that familiar to you?
Yes.
Excellent. What can you tell me about it?
That's how you find the slope.
So
M is the line.
m is the slope, and b tells us the y-intercept. Okay? Now I'm going to start at my y-intercept, and I'm going to use my slope to draw my line. Okay? Slope equals rise over run. We'll get to that in a second. So what do I know about this? Well, I know my slope, also called m, equals, well, it's 2/3. M is 2/3. Now it's also helpful to know that slope is rise over run. So if I have two numbers, which I do, I have a fraction with 2/3, I know that every time I go up 2, I'm going to go over 3. Okay, so when I'm drawing my graph, I'm going to end up going up 2 over 3, up 2 over 3. You don't need to draw that, but that's what it's going to look like. Always working, reading left to right. Now, what else do I know? I know my y-intercept. I know that the y-intercept is what?
-5.
-5. Okay, make sure you take the sign with you. Okay, that negative belongs to the 5. All right. This tells me a couple things. The y-intercept, and we can draw our grid. Your grid should look something like this. Would be helpful. X, Y, arrows at the end of the axes, because they go forever and ever and ever. Okay, the y-intercept tells me that this line is going to cross the y-axis at -5. Okay, so it's going to cross the y-axis at -5. So I'm going to just draw my -1, -2, -3, -4, -5, -6, -1, -2, -3, -4, -6. And I'm going to go ahead and draw a dot there at -5, the y-intercept. Does anyone know the ordered pair that belongs to that point? What's the x value at this point? Have I moved left to right along the x-axis? Nope. So the x value is 0. So this is going to tell me that the point 0, -5 is on the line, or that the line goes through the point 0, -5. Okay? What else do I know? Well, I know my slope. I know that if that point is on it, I can get to any other point by using my slope, the ratio of 2/3. So I'm going to go up 2/3. So I'm going to go up from -5 up 1, 2. And I'm going to go over. I didn't draw my points here, but you can do that as well. Okay, I'm going to go up 2 over 1, 2, 3. That's going to be my next point. Okay, and then I'm going to do that again. Go up 2 to -1 and over 3 to +6. Okay, my grid is not perfect because, well, because I'm just doing it quick on a whiteboard here. But once I have a couple of points, I can take my ruler and draw a line through those points. Add an arrow to the end of each end of the line. And what do I still need to do?
Y-intercept.
I need to label my line. I need to name my line. It's y equals 2/3 x minus 5. Okay, so this method involved using the slope and the y-intercept. Basically, if you find the y-intercept, which in this case is -5, it's right here in the equation, right? Nothing too difficult about that. There it is, y-intercept. So that tells you where it intercepts the y-axis, which is right here. And then you can find any other point by using your slope, which is also given for you right there, up 2 over 3. Okay, in this case, they're both positive, so it was pretty straightforward. Could do another example where one is negative or both are negative, but we're running out of time, so we're not going to do that. Okay? So the third method, method 3, so we have method 1 was use a table of values. That's generally never going to be the fastest, just so you know. Method 2, slope y-intercept. That is for easier equations. That's going to be pretty quick. That's going to be helpful, especially because you're most familiar with slope-intercept form of a line, y equals mx plus b. That's familiar to us. The third method involves using the intercepts. Using intercepts. What does that mean? Well, a line, unless it's perfectly vertical or perfectly horizontal, a line is always going to cross both intercepts. It's going to cross the y-axis somewhere, and it's going to cross the x-axis somewhere. If you can find both of those points, how many points do you have? 2. How many points do you need to draw a line? 2. So that'll work. If it's perfectly horizontal, it won't have an x-intercept. This won't work. If it's perfectly vertical, it won't have a y-intercept. This won't work. Okay? But those ones are so easy that you won't even have to do this. We'll get to those on another day. Using intercepts, our equation, our problem here, the equation of the line is 3x minus 4y equals 12. Okay, so you're going to look at that and you're going to say, wow, I don't like what that looks like at all. That looks really hard. I could convert this into y equals mx plus b form. It's going to leave me with a fraction. I don't really want to do that. So instead, I'm going to find both intercepts. Okay, to find x int, does anyone know what we have to do? Set y equal to 0. Okay? I know that where the line crosses the x-axis, the y-coordinate will have to be 0 because that's the definition of the x-axis. Every single point along this line, y is 0. Y hasn't moved down or up. It's just right here. Y is 0. Okay? So if I want to find the x-intercept, I'm just going to set the y equal to 0. Let's do that. So I'm going to rewrite the equation. 3x minus 4 times 0 equals 12. 4 times 0 is 0, so that's just going to leave me with 3x equals 12. I'm working a little bit quickly here, but that's okay. We're pressed for time. Now I'm going to divide both sides by 3. I get x equals 4. That tells me, therefore, 4, 0 is on the curve. 1, 2, 3, 4. All right. Same thing for finding y. To find y int, set x equals 0. So we'll do that. I'm going to rewrite my equation. Where I have an x, I'm going to put 0. Copy it down. 3 times 0 is 0, so that's just going to leave me with negative 4y equals 12. I'm going to divide both sides by negative 4. Okay, 12 divided by 4 is 3. And because I'm dividing a positive by a negative, the result is going to be negative. So the y-intercept is negative 3. That tells me that 0, negative 3 is on the line. 1, 2, 3. Okay? So if my line goes through 4, 0, and it goes through 0, negative 3, I've got 2 points. I can draw it. Okay? That was a lot easier than making a table of values, and it was a lot easier than converting into y equals mx plus b. I'm just going to label my line. This line is 3x minus 4y equals 12. Okay, there's your warm-up for 1.0, getting ready for Unit 1. You have some practice problems in your notebook, and you should do those by Monday in order to be prepared for 1.1.